If you shake your head at me, I'm gonna sock you one.
Oh, come on, Tom. Do you want me to help you or don't you?
Sure I do. But what gets me so mad is that I never used to have any trouble in arithmetic.
But algebra is just another way of thinking about numbers. The big difference is this. In arithmetic, you think about numbers in particular. But in algebra, you think about numbers in general. Look, you know why this is true, don't you?
Sure, there's some law.
The commutative law of addition.
That's right. I learned it in arithmetic.
Well, this is the way you say the same thing in algebra. Letters take the place of the numbers. The commutative law of multiplication would look like this in algebra. The associative law of addition, which is like this in arithmetic, would look like this in algebra. Here's the associative law of multiplication in arithmetic, and here it is in algebra. And the distributive law of multiplication with respect to addition can be expressed in both ways too, arithmetic and algebra. You use the same laws in algebra that you do in arithmetic. And you do the same operations, addition, subtraction, multiplication, and division. The only difference is arithmetic is particular and algebra is general.
Well, I think I understand that all right. But it's when I have to work with algebra that I get into trouble.
It isn't hard. Look, here's a picture of the company I worked for last summer. I could use algebra to describe all sorts of things about the company. For example, how many girls do you think worked there?
I don't know.
Then let's call the number n. That's not so hard to understand, is it?
No, we used n in arithmetic sometimes.
Then suppose they hired one more girl.
That'd be n plus 1.
Right. You see, we're using algebra now.
But that was easy.
Okay, let's do another. Let's suppose X tons of the company's product are being shipped in this truck. How many are being shipped in this truck?
How about y?
Fine. And how many tons are being shipped in this truck?
Z?
Okay. And suppose the company's full shipment for one day was represented by those 3 truckloads. How many tons would be shipped that day?
Well, x plus y plus z?
Plus z. Right. You see, letters represent numbers. Algebra is just another way of thinking about numbers.
Okay, but what about equations?
The same goes for them. They're part of algebra. All you have to do is put an equal sign here and set it equal to, say, T for total. And we have an equation. The sum of the tons in each of the trucks equals T, the total tonnage for the day. And suppose all this went to one factory, and the total was 125 tons. Then T would equal 125. You see, an equation is just like a sentence.
But is it right that an equation may not be true?
Sure, the same as any statement.
Then that's something I just don't understand.
Well, here's a statement. The moon is made of green cheese. True or false?
False. Okay, so a statement can be false. But what about equations?
Let's try another statement first. 3 plus 4 equals 7.
That's true.
Now, is this true or false? 3 plus n equals 7.
3 plus n equals 7?
That's right. Is this equation true or false?
I don't know. It could be true or false. You tell me what n equals, and I'll tell you which.
Now, don't you see? You could tell right away if all those other sentences were true or false. But not this one. This one isn't true or false. Not until we give n some particular value. If n equals 1, then the statement is false. 3 plus 1 doesn't equal 7. The statement is false if n equals any number except what?
4.
Right. 4 is the only solution to the equation. It makes the sentence true.
That's all an equation is. It's sometimes called an open sentence because you don't know whether it's true or not until the letter is replaced by a number. Then you solve the equation by finding the replacement or replacements which make it true.
I guess I understand. But you don't really use equations, do you?
You don't? Suppose you were in charge of the maintenance of this building. Suppose you wanted some repair work done, and you needed to know the area of the front part of the roof. How would you find it?
That's easy. It's a rectangle, so you measure the length and the width of the roof. The area equals the length times the width.
And that's an equation.
A equals LW? That's a formula.
But a formula is an equation.
You mean whenever you use formulas, you're working with equations?
That's right. For example, think about time, rate, and distance formulas. Distance equals rate times time. Rate equals distance divided by time. Time equals distance divided by rate. You know these formulas. Well, they're all equations. Even something as simple as this is an equation. The cost of shipping a company's product equals the rate per ton times the number of tons.
So algebra is just using equations.
No, I didn't say that. In fact, you can use algebra just as well to show that things aren't equal. For instance, suppose a baseball park holds 50,000 people. Then any time attendance should be less than 50,001.
Does this little mark mean less than?
Yes. This whole thing is called an inequality. An inequality like this is also an open sentence. Here's another one. Take a warehouse like the one this company owns. If it holds 100 tons of the company's product, you know that the amount that can be shipped out can't be more than 100 tons. So if 2 trucks do the shipping, and if X tons are in one truck, and U tons are in the other, then X plus U must be less than or equal to 100 tons.
But how do you use inequalities?
Well, in problems like this. Let's imagine 3 warehouses that the company owns in different parts of the country. Warehouse 1 can hold 100 tons. Warehouse 2 can hold 200 tons. And warehouse 3 can hold 100 tons. Now, orders come in from 2 factories. One wants 125 tons of the product, and the other wants 225 tons. Now, we want to keep total shipping costs as low as possible. The shipping rates are different from each of the warehouses to each of the factories. $1 a ton, $2 a ton, $3 a ton, $4 a ton, $5 a ton, and $6 a ton. We don't know the number of tons shipped from each warehouse. So let's think about the first factory and let X represent the number of tons shipped to it from warehouse 1. Y, the number of tons shipped to it from warehouse 2. And Z, the number of tons shipped to the factory from warehouse 3. In the same way, we can represent the number of tons from the 3 warehouses to the other factory with the letters U, V, and W. Now we can write some equations and inequalities. I'll give them to you and you write them down.
Okay.
X plus Y plus Z equals 125. That's because 125 tons in all are going to the first factory. U plus V plus W equals 225 because that's how much is going to the second factory warehouse. And we know that X plus U must be less than or equal to 100 because there are only 100 tons in this warehouse. For the same reason, Y plus V must be less than or equal to 200, and Z plus W must be less than or equal to 100. Now, If we call the total shipping cost C, then C equals the sum of the cost for each of the shipments. $1 per ton times X tons, plus $2 per ton times Y tons, plus 3 times Z, plus 4 times U, plus 5 times V, plus 6 times W. Do you have it written down?
Yes. C equals X plus 2Y plus 3Z plus 4U plus 5V plus 6W.
Fine. So you see, you have to find the set of values for all these equations and inequalities that give you the lowest value for C.
I'm lost. How do you do it?
Well, one way to do it is build yourself a little table like this. See? You keep trying different sets of values for these letters until you find the combination that gives you the smallest value for C in the equation. But unless the solutions are very easy, you'll probably never be sure. That's why a computer is usually used for solving this kind of problem. The hard part is setting up the problem, and that's where algebra comes in. Now, let's see if I've been getting through to you. How is algebra different from arithmetic?
Well, in algebra, you think about numbers in general,
Right.
but you use the same rules in algebra that you do in arithmetic.
Very good.
Letters stand for numbers, and when you put them equal to something, you have an equation. Equations can be true or false.
That's the idea.
You solve the equation by finding the numbers the letters stand for that make the equation true.
And how can you use equations and inequalities?
To show relationships between numbers. Did I understand what you were talking about?
You sure did. I think you see now that algebra is just a continuation of arithmetic.
Sure. It's just another way of thinking about numbers.